In this video, I introduce in-context learning distillation for large language models. In-context learning predicts output yk plus 1 given an input xk plus 1 conditioned on key in-context demonstrations from x1, y1 to xk, yk. Namely, find the probability P. In-context tuning optimize large language models with in-context learning objectives. Namely, using training dataset DT for task T to find the optimal large language model parameters theta. The in-context tuning objective is defined as here. ℒ trains large language models on ICT objectives with a large collection of tasks T meta. Meta-ICT objective is defined as a sum of ℒ 𝐼𝐶𝑇. Meta-ICT is trained on T meta to adapt new tasks. However, it ignores part of the label information in the input training data and cannot fully use the few shot training examples as shown here. This ICL and ICT, this meta-ICT. Multitask-ICT directly adapts large language models to target the tasks T target in two steps. First, it updates the model parameters with a few examples from target tasks in an in-context tuning manner. Then it makes a prediction via in-context learning, as shown here. This pre-trained large language model. First, this in-context tuning. Few examples from here, and also to the teacher model. Then the teacher model distills this student model in this in-context tuning. And then we use this in-context learning to predict the output y conditioned on x and the in-context examples. The objective for each task is to minimize the loss L, which is same as meta-ICT. Different from meta-ICT, multitask-ICT objective sums objectives across target tasks, as shown here, where T target is a target few shot tasks to evaluate. In-context learning distillation transfers in-context few shot learning abilities from large models to smaller models by combining in-context learning objectives LLICT and language modeling objectives LLM to distill both the ability of large models to read in-context examples and the task knowledge to the smaller models. The soft loss measures the discrepancy between the teachers and the student predictions, as shown here, where LLICT is ICT loss and LLM is a language model loss, as shown here. This soft loss this hard loss. The soft losses, ℒ and LLM, are defined as here, where T train is the training tasks in context learning, which is T mat or T target in Meta-ICT or in Multitask-ICT respectively. And the DLM is a supplemental open domain web text dataset. Students also learn from the ground truth. The hard loss ℒ measures the student's performance compared to the ground truth, as shown here and here. The final objective for in-context learning distillation is defined as here. LKD is equal to alpha times ℒ and 1 minus alpha times ℒsoft, where alpha is used to linearly increase soft label loss. For more details, please check with these references. Thank you. Bye.